Now this frame here is the base for our window to improve the visualization of smoothing groups. To remove these edges, we can apply the weighted normals modifier. And what this will do, it will remove all the sharp angles. Okay. Disable isolation mode. Now, in order to make all texture and materials display correctly, we need to set mapping for our table. Hi there. In the previous lesson, we modeled the walls, floor, and ceiling. We also set up a camera and scaled it using the perspective match tool. And so now we're going to model a window. The window has 4 openable segments, and each segment has its glass unit and frame. So to model a window fast and easy, I'm going to create a plane, first things first, and then I click on 3D snaps and create a plane. And then I rotate it by 90 degrees. Insert it into the window opening, and then I convert the plane into the editable poly. Then I click on point selection, and pay attention that I have 3D snaps and vertex mode enabled. And I also enable axis constraints, and I make the plane fit the opening. And we're using this object as a reference for a window frame. Alright, that's taken care of. Now the object perfectly fits in the opening. So then I go to the perspective camera view and click edge selection, and I select the upper and the lower edge and then divide them. Then I click connect and then drag this edge over to the center. So pay attention that I'm not using 3D snaps. Alright, now I select horizontal edges and also click connect. And now we have horizontal divider over here. Then I go to perspective view, and this is what we have. So then I select these polygons and apply the inset command. I model a frame around the window, and it's a small part of the frame. So maybe about 40 millimeters. It won't be visible on the perspective view. It's an outer edge. Next I apply inset, and I press F2 and see a red polygon. But now I change the setting from group to by polygon. And here I reduce the inset value to 30 millimeters. Now I detach the selected polygons. And I click on detach. And these polygons will serve as glass object. So then I select this glass object and move it aside. And in the future, when we'll be glazing the window, these elements will fit in perfectly. Now this frame here is the base for our window. And I use shell modifier to set the depth. Let's make it 50. Actually, let's go ahead and make it 60 millimeters. Alright, and so on the perspective camera view, I check how well it matches the main divider. It looks good, and we'll leave it like it is. And now we need to model the window wings. Convert this object to editable poly, and click edge selection, and then click on all corner edges. Then I click ring, and then connect. The number of edges, 2, and also increase the distance a little bit. And now, keeping the control button pressed, I click on polygon selection. And I got these highlighted areas. Then I click on Shrink to shrink the selection by 1 polygon. Then I click on Extrude and change the setting to Local Normal. So we have 3 modes here by Polygon, Group, and Local Normal. And I go for Local Normal. Then I set Extrude value to 20 millimeters. Then I go to Perspective View. The width of the glass unit is now clearly visible. And actually we can increase the value, and I undo the previous action and set the Extrude value to 40. Let's take a look at the Perspective View now. It's too much. And let's go ahead and change it to 30 now. So here you really need to try different values until you find the right one. The real window unit is about 35 to 40 millimeters. Alright, so now we need to see the last part that actually holds the glass. And let's do it this way. Select Inset and set the value to 10 millimeters. Actually, let's make it 8. Alright, and then I select Extrude and set the value to 10. And this will be the glass holder. On the Perspective View, I need to make sure that the width of the window unit matches the reference. It almost does. It's a little bit less. And I believe it's because the central part here is too narrow. And we should have made it wider. Anyway, you can adjust it if you want. I select a group of points. Now I lift it to set to the set value, and then I press F12 to open the Move Transform type menu, and shift the point up by 10 millimeters along the Z-axis. And now I select another group of points, and I keep Ctrl pressed. I shift them down by 10 millimeters along the Z. Now I select a group of points here, and I shift the X-axis by -10. And then I select this group here and shift it along the X by +10. And I close this menu. And the window frame and the glass unit fit almost perfectly. Now let's check the elements of the window block. We have flat segments, openable wings. The only thing missing is this central divider. Makes the window more detailed, so let's add it too. Keeping Alt Q pressed, I isolate the window frame. Create a box. Then enable Auto Grid. By snapping to the surface, I create a box. And it has a rectangular cross section. I convert it to editable poly, stretch it all the way to the edge by using 3D snaps. And also here I stretch to the edge. These areas will be hidden behind the curtains, that's why we won't refine them. In addition to this horizontal divider, we have a vertical one as well. And then I press Shift Ctrl and copy this element and rotate it by 90 degrees. And I'm using Angle Snap Toggle. Now I shift this element to the center of the window. And I sink it down a little bit so that when we apply chamfer to the horizontal element, the vertical element looks good. Alright. Now let's go ahead and align it a little bit using 3D snaps. Select the edges of this object and apply chamfer. Two edges, and chamfer is at 5 millimeters. Okay. Now I can apply chamfer to the rest of the elements as well. So I select loops with a double click and change the chamfer value accordingly. For instance, for this main element, I increase the chamfer value, and I also adjust edge and bias and edge radial bias. I zoom in and set smooth threshold to 28. Alright. Now, I don't know the precise values, so I'm setting rough values at this point. And then we'll use another modifier to improve the look of these chamfers. Then I'm gonna add one edge. Something like this. So select these edges. And here, the chamfer is smaller, so I apply chamfer, but set to a smaller value. Like this. Alright, and the last one, we can either go without chamfer at all, or set a small value, and I prefer to apply chamfer. So this will create a more sort of realistic glare when the object is lit. So I'll go ahead and reduce the number of edges. Alright. And now the window block has enough details. Increase its depth by scaling it along the Y to improve the visualization of smoothing groups. To remove these edges, we can apply the weighted normals modifier. And what this will do, it will remove all the sharp angles. And you can find it at the very end of the modifiers list. So I apply weighted normals, enable by edge angle, and set this value to 30 degrees. And now it will look more smoothed out and realistic. And I'm not going to change the rest of the settings. Now it all looks more or less realistic, so I convert it to editable poly. And I'm gonna paint it black. And so then I attach this element here. I'm gonna go to perspective view and paint the frame black again. And there you go, the frame is ready. If your dream is to become a professional 3D visualizer, I invite you to sign up for our full training course. Hundreds of people have completed this course, and you can see their graduation works on your screen right now. In 2 months, you'll learn the basics and move to more complex subjects. For example, how to set up a render, how to work with architectural materials, cameras, render, references, and much more. And at the end of the course, you too will have amazing graduation works like these. So click the link in the description to this video. Back to our scene. Alright, now let's model a table. So I hide the floor object so that we could see the table. I hide the wall as well. The window frame is not in our way, so we won't hide it. This is the reference box for the table. Let's use it to model a desktop. Convert the box to editable poly. Click point selection and select the bottom points. Disable 3D snaps. I go to perspective view to select all points. And I lift them so they match the lower part of the tabletop. Now I create a box for a table leg. The front leg is clearly visible. I create a box and shift it to where the leg is. Now I adjust its dimensions based on the visible part of the leg. The vertical elements need to match. Now I see that it's too wide, so I convert it to editable poly. I select the back side, select all, and then remove the selection from the elements that I don't need. Then I adjust the width, and then press F3 to disable the wireframe mode. And this is the leg object that I've modeled. Now I'm just going to paint it brown. And if you take a closer look at the photo, you'll see a small ledge there. See? So let's model it on the perspective view. So connect the edges. Press Ctrl and do a double click on this polygon. So we have this highlighted part. And I press Shift Scale. And here, now there's a small ledge. Delete the rest of the polygons. And I click on Grow and Delete. Now we need to check if all indents have the same width. There needs to be an indent here, and we don't have precise values. We have to rely on the reference photo. So align the indents so that everything looks proportionate. Now we can align the leg object relative to the tabletop. Select the leg and the tabletop and isolate them. I can align either the tabletop or the leg. Now let's leave the tabletop alone. Select the leg and enable the shift mode. Shift the leg along the x-axis to the center. And I don't think there'll be any displacements on the perspective view. But check all the same. If there's a displacement, then we need to move the leg a little forward. It should look more proportionate this way. And we might also adjust the width a little bit. And I'm doing this intuitively. And now, finally, it looks good on the perspective view. Alright. So the back part and the front part are both displaced. We can shift the leg to the left or to the right. Let's align it a little more, and we need to find the best position. Let's leave it here. Now I copy the back part of the table like this. Okay. On the top view, I found out that the leg needs to be shifted towards the front edge. And now, once it has been shifted towards the front edge, it is positioned right in the center of the table. I shift the leg, check the verticals, and now the leg is positioned correctly. I could shift it a little bit more, but it's already where it's supposed to be. So I attach these elements to a solid object. And I can do this on the perspective view. Stretch the legs to the tabletop. Attach these elements to a solid object. Now I apply chamfer for all edges. For wooden tabletops, this value is around 1.5 millimeters, typically. This edge is rather rigid, so I'll reduce the smooth threshold value. Okay. Disable isolation mode. Now, in order to make all texture and materials display correctly, we need to set mapping for our table. I drag this image of wood over here. Direction of its fibers is chaotic, so I click Element Selection. Then I press F2 to change the display mode. Select the UVW map modifier. Then click on Box, set dimensions to 1000 by 1000 by 1000. So that the scale is identical. Now rotate this gizmo box so that the direction of fiber is correct. And I need vertical fibers on the sides and horizontal on the tabletop. Then I click gizmo and start rotating it, looking for the position in which all the sides have vertical fibers and the tabletop has horizontal fibers. Copy the UVM modifier and select Collapse or Convert to Editable Poly. Now select the leg elements and do a right mouse click to paste the modifier with the right parameters, which is 1000 by 1000 by 1000. So I check the direction of the reference image, and here on the side parts the wood fibers are vertical, while those on larger surfaces are horizontal. So I select Gizmo box and rotate it by 90 degrees. Side parts are vertical, while larger surfaces are horizontal. Select Collapse 2 and click Yes. Okay, and now we've set the direction of the texture. So we've done basic mapping already, and that's it for today. We have ourselves a window frame, table, ceiling, floor, and even a reference object for the glass. Thanks for watching. See you next time.